Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we'll be talking about how do we solve trigonometry equations with simple angles. So in the previous video, I introduced the concept of cast diagrams, and I also talked about how do we get the angles and which of them is positive. And just to remind ourselves, in the last video, I told you about the cast diagram that it has 4 quadrants. So in the first quadrant here, all the angles are positive. In the second quadrant, sine is positive. In the third quadrant, tan is positive. And the last quadrant, cosine is what? Positive. And I also told you that for the sine for the second quadrant, to get the positive is 180 minus theta. The angle here to get it, the second angle is 180 plus theta. And for the fourth quadrant, to get the angle is 360 minus theta. And I talked about all this, all right? So like I always say, don't forget to like, share, and subscribe. And if you've not clicked on the notification bell, I don't know what you're waiting for, so that you'll be the first person to know when I post new videos. All right, so let's get into it. So how do we do this? So I'm going to just write down the trigonometry keys here that I want you to keep in mind. Now, this keys is going to be very, very important in solving simple angles, okay? So I'm going to do the same thing for both sine, I'm going to do for tan, I'm going to do for cosine as well. And it's very important that you review the previous videos where I talked about the sine graph, I talked about the cosine graph, and I talked about the tan graph, okay? Good. So let's start. So I'm going to start with the sine, okay? So if we're solving sine of an angle, okay? How do we go about it? Okay, so how do you go about it? So what you do first when you have in sine is this. The first thing you need to do is that you will need to find what we call the principal angle. So if you remember when we drew a graph, a sine graph, so I've talked about this already. So let's assume we have this particular sine graph. Okay, so I'm not just going into details yet. I'm just trying to explain the sine graph here. Okay, so sine graph, let's say something like this. And I told you the sine graph always starts from what? 0. Do you remember? So we have something like this, something like this. So it goes like this in the positive. And also we have something like this that goes like this. Permits my drawing in the negative. Okay. So let's assume we have, or let me see if I can draw that better. So something like this, like this. Oh, it's even getting worse. Uh, like this. Okay, I think this looks better. Okay, let's assume this. So this is a sine graph, and I told you the maximum you get is 1, and the minimum you get is -1. Now, what I'm trying to say here is that if we pick any angle here, let's pick an angle here. Let's call it angle X. It could be anything, okay? Now, what happens is that when you draw a straight line of angle X, okay? If you draw a straight line of angle X, from this point, you draw a straight line of angle X, all the way to the X-axis, and you also draw a straight line of angle X all the way to the y-axis, so to the negative x-axis. So you draw a straight line that it touches this curve. Now, what happens is that for angle X, the first place it touches here, you see, it touches at this point here. This is what we call the principal angle. So this P refers to the what? The principal angle. Okay? So P is the principal angle, and any other point that it touches in this place, in the curve, these are all the possible solutions for this what? For this angle. So if you come, so it touches at this point, this is a solution. All these are solutions, and all these are solutions. All these are what? Solutions. And all these are what? All the possible solutions you can get for this what? Particular angle X or result of X. Now, similarly, this can also happen if you have, if for instance, you have a negative value. So if let's assume X was negative. Let's assume we have X was negative. So we have X here. X was a negative. Let me put a red pen, maybe to make it to demarcate it. Let's assume X was a negative value. Do you understand? And we want to get all the possible solutions or all the possible angle that can give you that value X. The same thing, you draw a line that goes through all this, okay? You draw a line that goes through all this. Are you seeing it? Now, the same thing here. The first part it touches, is this straight? Let me see if I can make it straight. Yep, I think it looks straight now. Yep. So now the same thing, okay? The first part it touches here is also the what? The principal angle. Are you seeing it? Then all these values you are having here are all the possible solutions for this trig equation. So for this point, here's also a solution. So every point it touches the trig graph, all these are the possible solutions you can get. So all this here are all the possible solutions you can get for this. Is this making sense? So now, the question now is then, how do we get the principal angle? And how do we get all the possible solutions for this? Now, let's go back for sine. So I have a particular way I do explain to students, and it has helped loads of students, okay? I've taught several students and I've helped them. What I do, I just tell the students, I want you to just draw two lines here. So just draw a line here, okay? Just draw two lines. So the first thing is that you draw two lines. So now to get the first angle, okay? So you can call to get the first angle, or you can call it the principal angle, okay? So like here, I called it the principal angle. So you can call it the principal angle. Okay? That is P, all right? So for sine, what you need to do is that you need to find what? The sine inverse of theta. So the sine inverse of theta or the sine inverse of x, or anyhow theta, the angle you're looking at will give you the principal angle P. So in this case, we'll call this x. Or so in some textbook, you can see they'll write it as sine inverse of x. All right. Now you've gotten that. Okay. So, but because of consistency, so that I will not confuse you with any other thing, I'm going to just call it theta. Okay. Because I'm going to be using x in multiple angles as well. So I just want to be consistent with theta. Now, when you've gotten the sine, now you have to now get the second angle now. Now, the second angle, okay, this depends on the cast diagram. So remember we talked about the cast diagram? So we're going to use the cast diagram here. So for sine, we said sine was what? 180 minus what? Theta. So how do you now do that? So sine is 180 minus theta. So to get the second angle, if you're working in degrees, it's going to be 180 degrees minus theta. Or if you're working in radian, it's going to be pi minus what? Theta. And this is how you get the first and second angle. Now, the most important thing to get is the first and second angle. The other ones are very easy to get. So now when you've gotten the first angle and you've gotten the second angle, now when you're getting all the possible solution in the positive x direction, so if we're going down, so we're going in the positive x direction. So we're going now in the positive x direction. So if I go in the positive x direction, okay, what you do, you keep on adding what? 360 degrees. Or if you are working in radian, you keep on adding what? 2 pi radian. Okay? So if you're working in degrees, you'll be adding 360 degrees. But if you're working in radians, you add 2 pi radians. Now, the same thing, if you're going in the negative x direction. So if you're going in the negative x direction, so let's assume you're getting all the positive solutions in the negative x direction. Okay? The same thing, you'll be minusing what? You'll be subtracting 360 degrees. Or if you're working in radian, you'll be subtracting what? 2 pi. Okay? So for the first angle is the sine inverse of theta. The second angle is 180 degree minus theta or pi minus theta. Now, when you're going in the negative direction, you'll be subtracting 360 or 2 pi. When you're going in the positive direction, you'll be adding 360 or 2 pi. And that is that for sine. Now let's go to the next one. So don't worry, I'm going to solve examples for each of this, okay? But usually, like I usually say, I prefer to write down all the concepts and all the steps on how to solve it. Then after I'm done with that, then we can move on from there. So the next one, we're going to talk about tangents. So how do you get all the possible solutions for tangents, all right? So similarly, for tangent. So if you remember, I've talked about this earlier. So tangents, sorry, nope. So for tangents, so how does tangent graph look like? So we have, let's assume we have this, okay? Then let's assume we have this, and we have that as well. So let's assume we have this. And I also told you, so we have asymptotes. So I made you understand this. So please, if you've not watched my videos on the how to sketch all these curves, please, you have to go back and have a look. So I told you for tangent that we have vertical asymptotes as well at different points. So I told you, so let's assume we have at this point here, sorry. So let's assume we have at this point here. Okay, let's assume the vertical asymptote is here. We have another vertical asymptote here as well. Let's assume we have another vertical asymptote here. And you can also have at different places. So we have one here as well. Then we also have another vertical asymptote somewhere here. All right. Then also, I also explained to you the concept that it also goes from 0. Okay, so it's gonna go something like this, very close, but it's not gonna touch. It's coming here, same thing, close, and stuff like that. And you have another one, the same thing. It comes very close. It gets to the x-axis and comes very close. Then the next one, it comes like this, very close, like this, angles. So the same thing, we have something like this. It goes like this, very close, something like this. And we also have something like this as well. All right, so we have this for this, and we told you there's no maximum and there's no minimum for a tangent graph. Now, let's look at this carefully. So let's pick that we have a particular solution for this tangent graph. So let's pick any solution. Let me pick maybe, for instance, the same thing. We have an x value here, okay? An x value. I want to know all possible angles that can give you that particular x value. So the same thing, like I always say, so for the particular x value, so if you draw a straight line from this x value, okay, if you draw a straight line from this x value, everywhere it touches this curve are all the possible solutions for that, okay? So everywhere is going to touch this curve are all the possible solutions for this x value. So if you draw that, so yep. So that means if you look at this now, so the first part here that it touches, okay, this is what we call, this angle here is what we call, similar to what we did in the sine, is the principal what? Angle. Then any other place here that it touches are all the possible solutions for this graph. Are you seeing it? Are all the possible solutions for this angle. Now, even if x was a negative number, so let's assume the value we're looking for is a negative number somewhere in the negative region, and the same thing, and you want to also find all the possible solutions, that's what the same thing you would do as well. You draw a straight line, okay? And this straight line is what is going to be all the solutions for this. Is this making sense? So the first part, so in this example now, the first place he's touching is also going to be the principal angle. So this place here is going to be the principal angle P. Are you seeing it? And all the other parts that it touches as well are going to be all the possible solutions for this what? For this tangent as well. So how do you do this? Okay. Now, exactly the same thing, okay? Like I explained in the finding the sine graph, where remember in the sine graph, I told you you have to first find the first angle or the principal angle, second angle. Exactly the same thing you do here. So what I always say, so the first thing you do, you need to first find the what? The first angle. Okay, you find the first angle or the principal angle. Okay, and how do you find this? You use what? The tan inverse of theta. So like I said, or you can say the tan inverse of x, okay? But I'm going to prefer to use theta here just to be consistent throughout, okay? Now, when you've gotten that, to get a second angle now, that will be positive, or that will be the give you the same value as this first angle. So to get a second angle, now if you go back to the cast diagram, you will see that for the cast diagram, for tan, it is 180 plus what? Theta. So that means to get this one now, what you do is that to get the second angle, it's going to be, if you're working in degrees, it's going to be 180 degrees plus theta, or if you're working in radian, it's going to be pi plus what? Theta. Okay. And that is the most important angles to get. So when you've gotten these two angles, then as usual, similarly to the tangent, sorry, to the sine we talked about, when you're going the positive x direction, you add 360. So the same thing, when we're going down in the positive x direction. So if I'm going in the positive x direction, okay? What I'm going to do, I'm going to add 360 degrees, or if I'm working with radian, I'm going to add what? 2 pi radian. The same thing, if I'm going in the negative x direction, that means I'm going in the opposite direction. I'm going in the negative x direction. I'm going to be what? Subtracting 300 and what? 60 degrees. Or I'm going to be subtracting what? 2 pi, okay? So either I'm going to be subtracting 360 or I'm going to be subtracting what? 2 pi, and that is how you do this as well, okay? So for tangent, to get the first angle, which is the principal angle, you do tan inverse of theta. To get the second angle, will be 180 plus theta or pi plus theta. Now, to get the positive, into getting the positive direction, you need to be adding 360 or 2 pi. To get in the negative x direction, you need to be subtracting 360 or what? Minus 2 pi. Okay, so that is that. So we've talked about sine. We've talked about tangent, so now we're going to go to what? Cosine. All right, so let's go to cosine now, which is number 3. So how do we find all for cosine of a graph? Okay, so similarly, like I did in the other video, on the other angles, I'm going to draw the cosine graph. So if you remember, please, if you've not watched my videos on cosine, how to sketch graphs and the rest of it, this will be a very good time to go back and watch it. So for cosine graph, so if you can remember, I told you cosine, oh no, so get this out. Change this to thick lines. Yep. So we have something like this. Okay. Then we have this like this. So let's assume we have something like this. All right. Then we have something like this. Okay. So now for cosine graph, I told you as well that when you're drawing cosine graph, the maximum is 1 and the minimum is -1. We talked about this. But instead, we're going to be starting from 1, not from 0. Okay. So it's going to look like this, like this. So we talked about this the last time. Okay. So the same thing, it's going to be like this, like this. So we talked about this is how a cosine graph will look. Okay. So then, and let's assume now we have a particular value we're interested in. So let's assume here we have in x. So let's assume a value x here. Now, similarly to what we did in the last one, what you then do from that point x, you just draw a straight line. You draw a straight line, and that straight line is all the possible solutions for x for that graph. So you draw a straight line to where it touches. So like this. So if this is a straight line, or is that straight? Let's see. Yeah, like this. Okay. So you just draw just a straight line through that solution. Now, similar to what we talked about earlier, where it touches the first point here is going to be the principal angle. Are you seeing it? Then all these other points here, similarly, are all the possible solutions for what? For this angle. So all these points here are all the possible what? Solutions you can get. So when you look at it like this, so all these are the possible, you just draw a straight line, All these are all the possible solutions you can get. Now, if x, for instance, x is a negative value, so let's assume x is negative somewhere here, all right? Now, the same thing you're going to do is that you would then draw a straight line from x here, and anywhere it touches the graph, okay, anywhere it touches it, these are also all the possible solutions you can get for that. So for this, so these are all the possible solutions you can get. Now, the first part here that it touches, this part here, is what we call, is the principal angle as well. Okay, then all this as well are all the possible solutions for this angle as well. Okay, so all these are all the possible solutions for this. In the positive x and also in the negative x as well, all these are all the possible solutions you can get. Okay, so all these are all the possible solutions you can get for this graph. All right, so all these are the possible solutions. So that means then, if we have a particular angle or a particular value, then how do you now find this? Now, similarly to what I explained earlier, so we then use the same principle I did for the first angle and second angle when I was solving for sine and tan, okay? So the first thing I'm going to do is I'm going to first find the first angle, okay? So what I'm going to do is I'm going to first find the first angle. Now this first angle, or you can call it the principal angle. Okay, the principal angle P. And how do you find this angle? So for cosine, it's going to be the cos inverse of what? Theta. Okay. Now, when you found the first angle, the next thing is that you have to then find the what? The second what? Angle. Okay. Now, how do you find the second angle? So if you go back to the cast diagram we talked about, for cosine is 360 minus theta. So that means for cosine, for the second angle now, is going to become 360 minus theta. Or if you're working in radian, it's going to be 2 pi minus what? Theta. And this is how you get the first angle and the second angle. So now it is from these two angles now, you now derive the remaining possible solutions for this. Okay, so from these two angles, you derive that. So if you're going in the positive x direction, if you're going down, so this is in the positive x direction. In the positive x direction, you add what? 360 degrees. Or if you're working in radian, you add what? 2 pi. Are you seeing it? Now, but if you're going in the negative x direction, so if you're going in the negative x direction, what do? You subtract 360 degrees, or you subtract what? If you're working in radians, you subtract 2 pi radians. And that's how you get all the answers for this. I now know you'll be asking, Mr. Terry, how I'm getting confused. This looks like a lot. All right, don't worry. Remember I said, I promised you at the start of the video that I'm going to solve some questions on this, okay? So in my usual fashion, what I'm going to do now is I'm going to write the steps on how to do this. So I'm going to write the steps on how to get each of this. Then after I've written the steps, I'm going to pick some examples for us to solve. Okay. So let's write the steps now. Okay. How do we do this? How do you solve this? So usually there are 4 steps or 4 rules, okay, on how to solve this question. So number one. Now, how do you solve it? So the first thing you have to do is that you have to make sure that the trigonometric angle is alone on the left-hand side of the equation, and all other values is on the right-hand side of the equation. Okay? So you have to make sure, the trigonometry value or let's say trigonometry angle is alone on the left-hand side So I mean left-hand side, okay? So make sure that trigonometry angle is alone on the left-hand side of the equation. Okay? And all other values is on the right-hand side. So make sure the trigonometry angle is alone on the left-hand side of the equation, and all other values is on the right-hand side of the equation. Number two, okay? Now, when you've done this, the next thing you have to do is to find the trigonometry inverse, okay, to find the principal angle. So the sine inverse or the cosine inverse or the tan inverse. But one of the things that you need to keep in mind here is that when you're finding the trig inverse, you need to be sure that are you working in degrees or are you working in radians, okay? Now, if you're working in degrees, make sure you set your calculator to degrees. If you're working in radians, make sure you set your calculator to radians, okay? Because it's very, very important to keep that in mind. All right, so number two, we're gonna find the trigonometry inverse. Okay, so trig inverse, we're talking about either the sine inverse or we're finding so when I talk about inverse, so we're talking about either the sine inverse, so sine inverse of theta, or we're talking about the cos inverse of theta, or we're talking about the tan inverse of theta. So depending what you're looking for, okay? Now you're finding trigonometry inverse to find the principal angle. So I remember I called it the principal angle, or you can also call it the first angle. So the principal angle, or you can say the first angle. Okay? All right. So you can then find the trigonometry inverse, the sine inverse, the cosine inverse, or the tan inverse to get the principal angle of that. But one of the things I need you to take note of, okay, it's very important that I write this down, that you have to check whether you're working in degree or radian, and you have to check the range. So usually it's the range, I'll talk about that very soon, is the range that's going to let you know if you're going to be working in degrees or radian. So you have to then check the range. So it's very important that you check the range of the question. to see if you'll be walking in or solving in degrees or radian. But then you have to check the range of the question to see if you'll be working in degrees or radian, okay? So one of the key things that you can use to know is that if you notice that in the range, you notice maybe you have, let's say you see something like pi, you know it is in radian. If you see something like degrees, you know it is in degrees. So for instance, what I'm saying, so when you notice pi, okay, in the range, it means that they want you to work in radians, okay? And when you notice degrees, you see degree sign, okay? Then they want you to work in what? Degrees. So when you notice the degree sign, they want you to work in degrees, or if you notice the other sign, they want you to work in radian. Then when you've done that, then the next step is then you have to then find all the possible angles within that range using the trigonometry keys we talked about earlier, okay? And remember that when you're doing this, you have to stick to the angle units that you have in step 2. So basically, if you're having a degrees, you have to stick to degrees. If you're having radian, you have to stick with radians. And therefore, it is going to affect either you're working with 360 minus theta, like in cosine, or you're working with 2 pi minus theta, like in cosine, to get a second angle, okay? Don't worry, I'm going to solve an example on this. So number 3, what you now do is that you then find all the possible angles. So you find all the possible angles within the range. Okay, so within the range given in the question, using the three keys stated above. Okay, so what we talked about, finding the first angle for sine, cosine, and all the stuff. So you use it. But one of the things, like I always say, is that you have to remember to stick to the angle units. So you have to remember, okay, don't forget to stick to the angle units. Okay, so don't forget to stick to the angle units used in step 2. Okay, so if you have radians, you have to stick to radians. If you have degrees, you have to stick to degrees. So you have to make sure that you're using the right units for this. Okay. Then when you're done with that, when you found all that, usually you in some questions you could be asked to sketch the graph. So, but it's not really compulsory, it's optional. All right, but in some questions you could be asked to sketch. Okay, you could be asked to sketch. So it's usually optional. Okay, so this is usually optional. In some questions, you'll be required to sketch. In some questions, you might not be required. So, but what I'm going to do is that I'm going to sketch the graph. So just in case that in the exam questions you were told to sketch. Now, but one of the things I want to emphasize here is very important is that before we start solving now, I'm going to pick some example. I want you to know that you can change from degrees to radian or radian to degrees depending on what you're comfortable with. Because I noticed that for some students, they are very comfortable solving in degrees and not in radians. So what I advise students is that if you're very comfortable with degrees, but the question is in radians, you can solve in degrees, but at the end of the day, you need to convert it back to radian. Okay? Or if you're very comfortable with solving in radian, you can solve in radian, but at the end of the day, you need to convert everything back to degrees. So depending what the question is, okay? So I'm going to write that down here. So it's very important to note, all right? Because if the question if the question was in radian, it's expected that the answer you should give back to the examiner should also be in radian. But if you now decide to leave it in degrees, you might lose some marks, and sometimes you could lose a lot of marks for that. So, but what I say is that if you're very comfortable with degrees and the question was in radian, it's fine. Solve in degrees, but don't forget at the end to convert it back to radian. And it's a very good place that you need to go back and be very conversant with how to convert from degree to radian. I have a video on that already, so you can go back and have a look. So, so what I just said is that know that you can change, all right? So you can change from degrees to radian. Or vice versa, or radian to degree. Okay, depending on what, do you understand? What you're comfortable with, okay? So depending on with what you're comfortable, we now determine that, okay? But one thing I need you to remember is to change it back, okay? But remember to change it back. So remember to change back to the angle units, all right? Required in the question. So even if you're comfortable with degrees, but the question was in radian, work with degrees, but remember to change it back to radian, okay? All right, so these are basically the 4 steps, okay? You have to make sure the triangle is alone on the left-hand side of the equation and all other values on the right-hand side. Then after you're done with that, you need to find the trig inverse, or the sine inverse, the cosine inverse, or the tan inverse. Then also find all the possible angles within the range, and also you can sketch, okay? All right, so I think we've gotten to the point where we need to now what? Solve some questions now. So let's pick some examples so that we can bring this now back to life. So let's pick an example now, okay? So let's start solving. Let's pick an example and explain and how to solve this. So number 1, let's assume we have cos theta is equal to 0.5, okay? And we're told that theta is going to be between 360 degrees and 0 degrees, okay? So let's assume between 0 and 360 is theta. Now, step 1. So let's follow the steps I just explained. Now, if you go back, the first step was that we have to make sure that all the trigonometry angle is alone on the left-hand side and all the values is on the right-hand side. So let's go back to this. You will see. So all the trig angles, so yes, so in this question it was straight up. So it was cos theta is equal to what? 0.5. So you can see all the trig angles is on the left-hand side, and the values, the normal values you're looking for is on the what? On the right-hand side. Okay, good. Now let's go to step 2 now. So step 2, it said what? That we have to then find the trig inverse to get the principal angle, okay? So we have to find the trig inverse, but we need to check the range. So if you see here, when we have to check the what? The range to see if we're going to be working in degrees or we'll be working in what? Radians. Okay, so let's go back now and see what we have. So if you look at this, the range, you can see the range is in degrees. So we're having the range we're having here are both in what? Degrees. So you can see it's between 0 degrees to what? 360 degrees. So that means the range is in degrees. So that means we need to work in degrees, okay? So like I said earlier, if you're comfortable with radian, you can convert everything to radian, your calculator to radian, then convert it back to, but I usually say it's very easy, or it's more easier for you to work with the range given. All right, so we need to find the trig inverse now. So we know that cos theta, is equal to 0.5. So now at this point, you have to make sure that your calculator is in degrees. Then theta now is going to be equal to the cos inverse of 0.5. So you press your calculator now to give and make sure it is in degrees. So therefore, it will now be that theta, which is now the principal angle, okay, which is equal to the principal angle will be equal to what? 60 degrees. So when you press your calculator, you will see that the cos inverse of 0.5 is 60 degrees. All right, so step 3. So what does step 3 now say? Step 3 now say we should find all the possible angle using what? The trig keys. So let's go and look at the trig keys now. So we're looking for cosine. So we talked about cosine, okay? So we have the first angle, okay? Now we have the second angle. So now because we're working in degrees, we're going to use the 360 minus degrees to minus theta to find the second angle, right? So we're going to use this now. So let's go back. So step 3. Okay. So like I always say, then we'll have the first thing we have to do is we're going to get the first angle. We've gotten the first angle already, which is the principal angle. We got it to be what? 60 degrees. Now, how do we get the second angle? Now, from this to get the second angle, because we're working in degrees, it's going to be 360 minus degrees, minus theta, right? So it's going to become equal to 360 minus the theta here is what? 60 degrees. Are you seeing it? And this is going to give us what? 300 what? Degrees. So we've gotten the first angle and we've gotten the what? The second angle. Now, I told you as well that if you're going in the positive x direction, you keep on adding 360. If you're going in the negative x direction, you keep on adding what? Subtracting 360. All right, so because we're working in degrees, I'm going to be using 360 and minus 360. If, for instance, the range was in radian, then I have to use 2 pi and minus 2 pi. Does that make sense? But because in this case that it's in degrees, I have to work with that. So now, so how do we do that? Now, to get the third angle in the positive direction now, so to get the third angle, we have to keep on adding 360, right? So the third angle now, the third angle here in the positive x direction will be equal to, will be at 360. It's going to give us 60 degrees plus 360. And that will give us what? 420 what? Degrees. Okay. To get the fourth angle in the positive x direction. So this is the positive x. So we're now going the positive x direction now. Okay. The fourth angle in the positive x is going to become 300 degrees plus what? 360 degrees, and that will give us 660 what? Degrees. And you can keep on going again and again, and you can keep on adding. Okay, but I'm going to just stop here. I'm going to tell you why I'm going to stop here. Don't worry, you'll know it very soon. Now, also, I can also go in the negative direction, okay? So the third angle here in the negative x now. So I want to go in the negative x direction. So the third angle now, I want to go in the negative x direction. It's going to become 300, right? Minus 360 degrees. And this is going to give us minus what? 60 degrees. To get the fourth one in the negative x direction, the fourth angle is going to become 60. So remember, you keep on subtracting. Minus what? 360 degrees. And that will give us minus what? 300 degrees. And you can keep on going all the way till infinity. But which of these are going to be my answer? You have to now look at the range. Now, they are only interested in answers between 0 and 360. So because they are interested in only answers between 0 and 360, so if you look at what I have here, the only ones that fall between 0 and 360 is going to be this one and this one. So these ones are not part of the solutions. They won't be part of the solutions. They will not be part of the solutions, and that will not be part of the solution. So that means for this example now, the value of theta, okay, that is the solution here, is going to be what? 60 degrees and 300 what? Degrees. Okay? So if, for instance, the 7 be between 0 and 720, then I'll take this 420 and 660 as well. Okay? So it's the range that is going to determine where to stop. Okay? So it's important you know that. So the range is going to determine where to stop. So maybe I can write that down here as the fourth one. Okay? So the range will determine when to stop or where to stop. Okay? So the range is going to determine where to stop. So depending on the value you have, is going to determine where you're going to stop. Is that okay? So that's what the range is going to do. So now we're done with that. But step 4 now said that you can be asked to sketch. So in this example, I'm going to try to sketch. So we're having cos theta is equal to 0.5. Okay. So usually what I do is I will just try and sketch the graph so that it will be easy. So this is step 4, right? So let me write it down. So step 4. Okay. So step 4, let's sketch this graph. So we have something like this. Okay. Then we have something like this. Okay. So remember for what do you call it? Cosine graph, the maximum we have is 1 and the minimum we have is -1. So I've done this already in previous video, and I also told you that so in degrees we can now do 90 degrees. So this part here is going to be 90 degrees, or let's make it 3 to make it a little bigger. So this is 90. So let's say this is 90 degrees. This is 180. So we'll go in 180 degrees. Then this is going to be 270 degrees. And this is going to be what? 360 degrees. Then you can keep on moving to infinity. So the same thing as well. So this is going to be minus 90 degrees. This is going to give you minus 180 degrees. This is going to give you minus 270 degrees. And this is going to give you minus 360 degrees. So I told you that when you're drawing this, that for cosine, you start from 1. So you have 1. The next one will be 90. That is somewhere here. 180 is going to be somewhere here. 270 and 360 will be back to 1. Okay. Then the same thing, we're going to have minus 90 here. Minus 180 should be somewhere here. Then we have 270 should be here. And 360 should be back to 1. Okay. Then you can now join these points together. Okay. So you have this like this. Permit my drawing. Okay. Like this and like that. Then also you have it like this. Okay. And you have it like right. So you have it like this all the way to this point. Okay. So now that is the cosine graph. So I've talked about this earlier. Now let's go back to the question we have. So the question we said it was cos theta is equal to 0.5. So that means the value we're looking at for the x here. So this is 0.5. So somewhere here, 0.5. So like I said, with 0.5, we need to now draw a straight line from 0.5, and it's going to give us all the possible answers for this. So then the same thing. So we have this. So draw a straight line. Okay. From 0.5. So we draw a straight line for that. So 0.5. So this is the straight line. So remember I told you the first point he touches here is the what? The principal angle. Then all these values here are all the solutions for this graph. Are you seeing it? So the first angle it touches here, the principal angle, and we found that angle to be what? The principal angle to be 60. So that means this point here is what? 60 degrees. Then the second angle that we found here was 300. So you can see this point here is going to be what? 300 degrees. Now, there are other solutions, but because we're only interested between 0 and 360, so this was the range that we're only interested in, and that was the reason we only selected these two values as our answer. But if you look at it closely, there are several answers as well. So you can see, we can see here, there's a minus 60. Are you seeing it? There's a minus 60 that we calculated here, which was there. Also, we also have a minus 300. But because we are only interested between 0 and 360, so that's the reason we only select 60, and we only selected what? 300 degrees, okay? And that is how you sketch it. So like I said, it depends. Some questions might ask you, and some questions might not ask you, all right? So it depends the kind of question you have. So the range was between 0, x, and what? 360 degrees. So this is the interested range we have. So that's the reason why we have to what? Stop here. Okay? All right, let's pick another example. So we've picked one about cosine, cos theta equals to 0.5. Let's pick another example, number 2. Okay, let's pick another example. Let's say we have 4 sine x plus 3 is equal to 0, and we have it between this time minus 720 degrees x, and we have 720 degrees. Okay, so now let's go back. So we have step 1. So like I said, you don't need to show the steps in when you're solving. You can just go through. But because I'm teaching a large audience of students, so what I do is I show all the steps I have in my mind and try to write it down. Then as we keep going, you'll see that when you become very good at this, you will see that you don't need to write down the steps. You just solve it in a blink of an eye. Okay. So let's go. The step 1. So the first step was that we need to make sure that all the trig angle is alone on the left-hand side of the equation and all other values on the right-hand side. So like I said earlier, we need to make sure only the trig angle is on the left-hand side and all other angles will be on the right-hand side. So let's go. We'll have to play with this till we get to that point. So now, but you can see here, we have trig and numbers everywhere. So we have to make sure the trig is on the left-hand side and the values are on the right-hand side. So let's go. So we'll try with this. So we have 4 sine x plus 3 is equal to 0. So I'm going to take 3 to this side. So because I need the sine trig to be on its own, so it's going to give me 4 sine x will be equal to minus 3. And because of this, I need the trig to be on its own. I'm going to divide both sides by 4. So I can get rid of this 4 here. And this 4, we cancel this 4. Then we're going to have sine x will be equal to minus 3 over 4. And minus 3 over 4 is the same thing as saying minus 0.75. So therefore now, we can now say sine x is equal to minus 0.75. Okay, so you can now see we've gotten to the point that the trig is on its own on the left-hand side and all other values are on the right-hand side. Okay, so step 2, we can now proceed now quickly to step 2 to solve. Now, what is step 2? So step 2 now is that we then have to then find the trig inverse, but we need to check the range first, right? So let's go. Now, if you look at the question as well, we can see that the range that was given was in what? Degrees. So you can see the range was in degrees. This is 720, not 72. So this is 720. Okay. All right. So you can see that the range that was given was in degrees. Are you seeing it? So that means if the range is in degrees, so that means they're expecting us to walk in degrees. So the range that was given was in what? Degrees. So because it's in degrees, we have to walk in degrees. So you go to your calculator and you set your calculator back to degrees, okay? Now let's move on. So we now have sine x is equal to minus 0.75. Or you can say sine x is minus 3 over 4. So it depends. So if you prefer, the best thing to do that I always tell students, I prefer to make sure it's in fractions than in decimals. Okay, so because in fractions you have to round up for degree of accuracy. So that means I can write sine x with this, or you can say sine x is equal to minus 3 over 4. Okay, so but because of accuracy, I will prefer to use minus 3 over 4. Is that okay? So I'm going to use minus 3 over 4. So sine x is minus 3 divided by 4. Okay? Now, to get the x, what do? You find the sine inverse. So the x is going to be equal to, which is the first angle or the principal angle. So the x is going to be equal to the sine inverse of what? 3 over 4. Okay, the sine inverse of 3 over 4. And this is going to give us minus, I think, 48.59. Okay, minus 48.59. So now we can now say x, which is equal to the principal angle, or you can call it equal to the first angle in this question. All right, equal to the first angle is equal to minus 48.59 degrees. Okay, so we've gotten our first angle to be that in step 2. Now let's move on. Step 3 now, we need to then follow the 3 keys for this, okay? And in this example, we are having sine. So let's go to the 3 keys for sine. So sine, I believe, was the first one we talked about, okay? So to get the first angle is the sine inverse of theta. The second angle is 180 minus theta because we're working in degrees. Does that make sense? Then we'll keep on adding 360 and we're going to subtract what? 360. All right, so that's what we're going to do. So let's go. So the first angle and the second angle, and we'll keep on going that way. All right, so step 3. Okay, and remember, we're only looking for answers between minus 720 and 720. Okay, we're looking between minus 720 and 720. So you need to keep the range in mind when you're doing this. So let's go, let's start. So we have the first angle. So the first angle, um, so the first angle, that was given, we have is minus 48.59 was minus 48.59. Now the second angle, okay, the second angle will be, now when we go, how do you get the second angle for sine? It's going to be 180 minus theta, okay? So 180 minus theta, so let's go. So we're going to have, it will be 180 minus, but theta here, our first angle is minus 48.59. Are you seeing it? Now, when you press your calculator for that, it's going to give you 228.59 degrees. So we've gotten the first angle, and we've gotten the what? The second angle. Now, if you go back to the 3 keys, I told you that when you're going in the positive x direction, you add 360. And when you're going the negative x direction, you subtract what? 360. And remember, in this question, the range that we're given is between what? Minus 720 and 720. So that means we'll keep on adding here in the positive till we get to 720. So when we get to 720, we're going to stop. So that means for this, we need to stop when we get to 720, positive 720. We'll keep on adding 360 until we get to 720 and we'll stop. But in the negative x direction, we need to keep on subtracting 360 until we get to what? Minus what? 720, and we're going to what? Stop. Okay, so let's see. Let's start with the positive direction, all right? So now we've gotten the first angle and the second angle. Now to get the third angle in the positive direction, we're going to be adding what? 360. So it's going to become minus 48.59 plus 360 degrees. And that will give us 311.41. Now, 311.41 is still less than 720, so we keep going, all right? Now, we go to the fourth angle. Now, the fourth angle is going to become, we'll add 360 to the second angle, so it's going to be 228.59 plus 360. And what is this going to give us? It's going to give us 588 point what? 59. 588.59 is still less than 36, still less than 720. Then we'll keep on what? Moving forward. Okay, so we'll go to the fifth angle now. The fifth angle, what do we have? We keep on adding 360. So we have 311.41, okay, plus 360. And this is going to give us 671 point what? 41. 671.41 is still less than 720. We keep on going. We'll now go to the sixth angle. The sixth angle is going to become, we have 360, 588.59 plus 360. And when you add this, it's going to give you 948.5 what? 9. 948.59 is greater than 720, so we have to now what? Stop here. So we're going to reject this. So we're going to stop here. Are you seeing it? So that means on the positive sides, the only values that we need are what? 67.41, 588.59, 311 point this, okay? Now let's go to the negative axis. So this is the positive direction. Let's go to the negative direction now. So now let's go. So to get the third angle, now the third angle now in the negative direction. So the third angle in the negative direction. So you start from the second angle now, you'll be subtracting 360. As you're going up, you'll be subtracting. So it's gonna give you 228.59. Are you seeing it? Minus 360 degrees. And when you press your calculator for that, it should give you minus 131 point what? 41. Minus 131.41 is less than 720. So we'll keep on going. Now to get the fourth one in the negative direction, will also be minus 48.59 minus what? 360. So when you're going up, you subtract what? 360 degrees. And that will give you minus 408 point what? 59. Minus 408.59 is still less than 720. So we keep on what? Going. We don't stop. Now we go to the fifth angle now. Okay, we'll go to the fifth angle. Now we have it. You start with the 131. So it's going to be minus 131.41 minus what? 360 degrees. Okay. And when you subtract this, it's going to give you minus 491 point what? 41. Minus 491.41 is still less than 360. Sorry, still less than minus 720. Then we keep going. We'll go to the sixth angle now. So we have minus 408.59 minus what? 360 degrees. And this is going to give us minus 768.59. So you can see minus 768.59 is greater than minus 720. So we have to stop there. So now we can now say the answers that will be here will be minus 491.49, minus 408.59, minus 131.41, and definitely our two first and our second angles. So all this now will be the solutions for this what? Graph. So that means for this now, we can say, was it theta that was the question, or x? X, right? So that means here, the x that will be within the range is going to be the first one, which was minus 419.41. So we have minus 491.41. The next one we had was minus 408.59. So minus 408.59. The next one was minus 131.41. So we have minus 131.41. The next one was minus 48.59. The next one was 228.59. Okay. The next one was 311.41. The next one was 588.59. And the next one is 671.41. And the next one is sorry, that is the last one. But the other one is not part of it. So it's going to be this and 671.41. And now, the interesting thing I forgot to mention earlier is that if you press any of this in your calculator, you press sign minus 491.41, you will see that no matter which one you press, you're going to get minus 0.75. The same thing with the previous example. If you press cos 60 and cos 300, the same thing, you're going to get 0.5, okay? And that's how it is. So that's how you solve the example. But in some cases, you might be asked to sketch, so we're going to sketch it now. So I'm going to try to sketch the graph. So just in case you're in an exam and you're told to sketch this, okay? So remember I said step 4. This step is optional, okay? Step 4 is always optional. In some exams, you might not be told to do this. In some, you might be told to do this, okay? So you need to just keep that in mind that you will not necessarily be asked to do that. But in a case that you're asked to do it, it's going to be easy for you to do. Okay, so let's go. So let's sketch this graph. So let's have something here. Okay, and let's draw something here, maybe this point here, okay? All right. And while having between this and 720, so let's assume, let's push it to this point here. So you can have some space. So now because it's between 720, it will be between, let's say, that is 2 revolutions. 1, 2, 3, 4, 5, 6, 7. Okay. Let's see. How can I divide this? 1, 2, 3, 4, 5, 6, 7. Okay. So let's do it that way. So we have, and it's in degrees. So this is going to be 90 degrees. This is going to be 180. This is going to be, so you keep on adding 90. Okay. So this is going to give you 270. This is going to give you what? 360 degrees. So all these are in degrees, okay? Then you keep on adding 90. So this is going to give you 450, okay? You keep on adding 90, it's going to give you 540. Then you add under 90, it's going to give you 630. and you have another 90 is going to give you 720. So because the range is up to 720, so that's why I'm going to stop in 720. All right. So I'm going to do the same thing. I'm going to have this. So it's going to be minus 90 degrees. So all these are in degrees. So you're going to have minus 180 degrees. You're going to have minus 270. Then you're going to have minus 360, all in degrees, okay? Then you're going to have minus 450. We're going to have minus 540. We're going to have minus 630, okay? And you have minus 720. So all these are in degrees, okay? So all these are in degrees. And like I told you, the maximum number you can have is 1. So let's draw this a bit up. So let's put it, the maximum number you can get is 1. And 1, 2, 3, 4, 5, 6. So 2, 3, 4, 5, 6. And let's say we have somewhere here minus 1. Now that is it. So the trig graph we have here is a sine graph. Okay, so if you remember what I taught you for sine graph, the minimum you have to start from 0. So a sine graph starts from 0, then goes all the way to 90, comes back to 180, then goes to 270, okay, goes back to 360, then goes back to 1, okay, then comes back to 0. So it's a wave. So we talked about this, then goes down to 630 and goes all the way to 720, okay? So you add this all the way like this. It goes up, comes down, comes like this. So it goes up, okay? Then it comes down, then goes up the way back. So the same thing you do for minus 90. So it's going to be minus 1, then goes down to minus 180, then goes to 70, goes to 1, then comes back to minus 360, then 450 is going to be minus 1, then 540 is going to be 0, then this is going to be minus 630, and it's going to give you minus 720 here. So the same thing, you join the points. Okay, so you join the points. There's gonna be something like this. So like this. So this is the graph. Okay. Whoa, finally we got there. So what we are now saying, so we're now looking for, we know that sine x was minus 0.75, okay? So we're looking for value of minus 0.75 or minus 3/4. So let's assume in this example, okay, let's assume this point here was it minus? Let me check again. Was it minus or positive? Minus. So that means minus should be somewhere here. So let's assume this was the minus 0.75. Okay. Now, because it's minus 0.75, so as usual, you then have to draw a line from minus 0.75 to give you all the possible answers for this. Okay, so remember, like I told you, anywhere it touches it, so those are where the values for it. So, yep, and that's minus 0.75. So you can see it touches the curve at this point here, this point, this point, this point, there's point, there's point, there's point, and there's point. So you can see that it's having how many solutions? 1, 2, 3, 4, 5, 6, 7, 8. And if you look at the graph, the question we just solved, we have 1, 2, 3, 4, 5, 6, 7, and 8. So you see, we still have 8 solutions, similarly to what the graph showed. Now, remember I told you that where it touches it first is the principal value. So now if you look at it here, the principal value is going to be this one here. So this is the principal value, and we had it, the first angle was minus 48 point what? 59. So this was the first one. It's going to be minus 48.59. Okay. Then this here was the what? Second value. Okay. So in order to make it easy, I'm going to put it in alphabet. So this is going to be A. Now in this positive, so now we're doing the positive X direction. So now this one here is going to give you the what? The B. This is going to be the what? The C. And this is going to be the what? The D. Now, if you look at our solutions as well, okay, if you look at our solutions, now the positive one, the first one we have is 228. So that means this is going to give us 228.59. Now, this other one here is going to be the 311.41. Are you seeing it? Now, the C is the 588.59. And the D is going to be the what? 671.41. Okay, so that was that. Now the same thing as well you can do for this. So if you drag this all the way up, it's going to give you the answer. That's for the negative X now. So it's going to be E. You drag this all the way up. It's going to give you F. And you drag this all the way up. It will be the solution. It will be the solution for this, and it's going to give you what? G. Are you seeing it? So if you now see the E now, this is minus 49. So for this one, it's going to be the minus 131.41. This is going to be the minus 408.59. Are you seeing it? And this is going to give you the minus 491.41. All right, and that is that for that. So like I told you, some of the questions might ask you to draw it to show the solution so you can see, but some might not, okay? So yeah, regardless, you should be fine to draw any of them. All right, so let me pick one more. Okay, let me pick one more example for this. So let's pick one more. So let's assume I have this question here. So for this example, so let's assume, let's say number 3, okay? Number 3, we have tan theta will be equal to minus 1 over square root of 3. Now, but this time, the range is a little bit interesting. You're seeing the range now is between minus pi x and what? 2 pi. Are you seeing it? It's between minus pi x and 2 pi. So now, let's go. So we'll start with step 1 first. Okay? We start with step 1. So what is step 1? We're told in step 1 that we have to make sure the trig angle is alone on the left-hand side of the equation and all the values on the right-hand side of the equation. So we can do that. So if you look at this as well, we have tan theta. It's already on the left-hand side, so it's very easy and straight to the point. There's no need for rearrangement in this question. So the question was already arranged, but remember, like in the second example, if it was not arranged, you have to do the rearrangement, right? Good. Now let's go to step 2 now. Now, step 2. Okay? Now, what is step 2? Let's have a look. Now, step 2 now said we need to find the trigonometry inverse, okay? And we need to check the range to see if it's in degrees or radians. So if you now go back to this, now, and you look at the range, you will notice that the range, like I told you, the range here is in what? Pi. So because it's in pi, all right, we need to work in what? Radians. Are you seeing it? So they want you to work in radians. So at this point, you go to your calculator and make sure you change the settings, okay, of the angle unit. You have to change it to radians. So that means the range here that we're given was in what? Radians. Okay? So that means we'll have to change the settings to radians. Now, after you've done that, we can now find the inverse. So the theta now will be equal to the tan inverse of minus 1 over square root of what? 3. Okay? Now, and when you press your calculator, this will give you around now, remember this is in radians now, to give you minus 1 over 6 pi. Okay? So usually I prefer to write this in exact form pi, or you can also have it in decimals. Okay? So you can also change it to decimal form, but I prefer to write it in exact forms because it's just very easy to work with. Or another thing again, if you are very comfortable with degrees, you can solve these questions like we've solved earlier, all in degrees. Then at the end of the day, the final answer, you convert it back to radian. Okay, so you can do that as well. You get the same thing. So, so with this now, we can now say the theta, okay, which is the same thing as the principal angle. Okay, or is equal to the first angle. So any terminology you prefer, equal to the first angle will be equal to minus 1 over 6 what? Minus 1 over 6 pi. So it's going to be pi radian, okay? So you can call it pi radian. Pi radian, okay? So it is in radian. So that's what we're trying to say. All right, so we're done with this now. So we need to now go and go to step 3. So let's go to step 3. Similarly, we need to find the first angle, find the second angle, and stuff like that. Okay. So I think now we are big boys and girls, so we don't need to go to the steps. We can just go straight and have a look at it. Now, for this question, we are looking at the range between minus pi and 2 pi. Okay. So we can get the first angle. We know the first angle. Okay. The first angle here, we got it to be what? Minus 1 over 6 pi. Does that make sense? So it is minus 1 over 6 pi radian. Now, for some of you, when you press your calculator for this, it will be around minus 0.52, okay? All right. Now, how do you do this? Now, let's look at the range again. The range we're told is between minus pi and 2 pi. So that means we're having between minus pi, was it x or theta this time? X. So, and what? 2 pi. Now, what I always advise students is because some of us are not really comfortable with fractions, okay? What I always advise students is that convert this to fractions, to decimals. So when you press your calculator for this, for decimals, we know that pi is the same thing as saying minus 3.142, okay, or minus 3.14. Now, and 2 pi is going to be around 6.28. So what they are trying to say is that they want that the maximum number you should get should be 6.28, and the minimum number should not be less than minus 3.142. So that means the number should be greater than minus 3.142, but it should be less than 6.8. So it's very important to do these extra steps here to convert it to decimal if you are not very, very comfortable working with fractions. So that means the minus 1/6 pi is the same thing as 0 minus 0.52. Now, how do we get the second angle for tan? Okay, so the second angle. So if you go to the stuff, so we're looking for tan now. So how do you get for tan? So tan is equal to 180 plus theta or pi plus theta. So now in this case, because we're working with radian, so we're going to use the pi plus what? Theta. Then we'll now be adding 2 pi. So we'll add 2 pi when we are going in the positive x direction. We'll add 2 pi. Or we subtract 2 pi when we are going in the negative what? X direction. So let's go. So going back there now. So because we're getting it, so we're going to be having pi plus theta. So because that's how you get the second angle, pi plus theta. So let's go there. So it's going to become pi plus, what the theta? Minus 1/6 pi. Are you seeing it? And this is going to give you 5/6 pi. And when you press this in your calculator, it should be the same thing as 2.62. So the same thing as 2.62. So we've gotten the first angle. Okay. And we've gotten the second angle. So now, as you know, we need to, when we're going the positive x direction, we need to keep on adding what? Now, 360, but now because we're working in radian, we need to be adding what? 2 pi. So when we're going the positive x, we'll be adding 2 pi. And when we're going in the negative x, we'll be subtracting 2 pi. So, but the maximum number we need to get, minimum number should be minus 3.14. When we get to minus 3.14, we stop. But for the when we're adding, when we get to 6.28, we are going to what? We're going to stop. So let's go. Now let's start with the positive angle first, or the positive x direction. So the third angle now, the third angle will be equal to, you'll be adding 2 pi. So it's going to be minus 1/6 pi plus 2 pi. And what would this give you? It will give you 11/6 pi. And when you press it in decimals, it's going to give you 5.76. So 5.76, you can see 5.76 is less than 6.28. We need to keep on going. We're going to get the fourth angle now. Now the fourth angle is going to be 5 over 6 pi plus 2 pi. And when you press your calculator, it's going to give you 17 over 6 pi. Now 17 over 6 pi is in decimal is going to give you what? 8.90. So 8.90 is greater than 6.28. We're going to stop here. So that means in the positive x direction, the only one that is we're going to pick is going to be 11 over 6 pi or 5.76. All right, let's go to the negative direction now. Now, in the negative direction, we need to get the third angle. So the third angle, we have to now be subtracting what? 2 pi. So we're going to have 5 over 6 pi minus 2 pi. All right? And when you press your calculator, it's going to give you minus 7 over 6 pi, which is the same thing as saying minus 3.67. Minus 3.67 is already above minus 3.142, so you just have to stop. But just for completeness, I'm going to just get a fourth angle. Okay, I'm going to get a fourth angle just for completeness. So the fourth angle in the negative direction is going to be minus 1 over 6 pi minus what? 2 pi. So minus 1 over 6 pi minus 2 pi is going to give you minus 13 over 6 pi, which is the same thing as minus 6.81. And as well as expected, minus 6.81 is still less than minus 3.14. So you're going to stop here. So that means we are not taking any values from the negative x direction. So that means for in this example here, the only answers that are within the range that we're looking out for is minus 1 over 6 pi and 5 over 6 pi. All right. So that means we can now say for this question, just to make it easy, I think I should have put theta here, not x. Okay. So theta. All right. So for this now, we can now easily now say that the values for, let me clean this to make it easy. So I'm going to, it's meant to be theta because we're working with theta here, not x. Okay, theta. So to make it easy now, so we can now see that the values that we are looking out for are between these this range here. Good. Right, let's move down to this point here. So take it down. So now the solutions that we have for theta now, the solutions for theta. So theta, the answers for theta is going to be minus 1 over 6 pi, or if you are writing it in decimal, it'll be minus 0.52, or you can say 5 over 6 pi, and if you're writing it in decimals, it's going to be around 2.62, and 11 over 6 pi, and if you're writing it in decimal, it's going to be 5.76. And those are the answers we have. All right, so step 4, remember I always tell you step 4 is optional. In some questions, they might ask you to sketch it, okay? So it's usually optional. So some exams will ask you to sketch. Some is not going to ask you to sketch, but in this case, I'm going to do both for you. All right, so let's draw this now, okay? Let's see. So let's assume we have, let me use black for this. So let's draw this. So we have something like this. Then let's say we have like this. Make this a bit straight, a bit, yep. Now, we're gonna draw the graph for this. So like I told you, because we have the range in radian, so we're gonna do this in radian as well. So instead of having it as 90, 180, we're gonna put it in radian. So it's gonna be, this is gonna be pi over 2. This is gonna be pi. Okay. This is gonna give us 3 over 2 pi. And this is going to give us what? 2 pi. So because we have it in radian, okay, then the same thing we're going to have here is going to be minus pi over 2. We're going to have it as minus pi. We're going to have here as minus 3 over 2 pi. And we're going to have here as what? Minus 2 pi. Then the next step is that we're going to draw the where the vertical asymptote is. So the vertical asymptote is at 90. So we're going to draw it here. Okay. We have vertical asymptote at 90, and also have the vertical asymptote as 3 over 2 pi. Okay. So we have it as 3 over 2 pi. All right. So push it a bit. Be on that. Yep. And push this a bit to be on that. So that's what the vertical asymptote is. Then the same thing, we're going to have the vertical asymptote as well to be on the minus pi over 2. So it's going to be somewhere here. They also have the vertical asymptote to be on minus 3 over 2 pi. Okay, and that is that. Now, what was the range for this question? Was it, I think it was not up to 2 pi. Let me just check. It was between minus pi and 2 pi. Okay, minus pi and 2 pi. So that was it. Then, like I told you, we're gonna draw. So it goes through the x-axis. Do you remember? So it's gonna be something like this. Very close. Come here, close, and go all the way up. Okay. The same thing. It's gonna be like this. It's gonna be very close. Go through pi and go all the way up. Then it's gonna be like this, all the way very close and stop. Then the same thing. So the minus pi is gonna be like this. It's gonna be very close. Go through minus pi. Sorry for that. So it's gonna be like this. Go minus pi, go all the way up. And it's gonna be like this. Go all the way up and go down. All right, so we've talked about all this before. All right, so something like this and like that. So, but we are interested, the range we're interested is between, if I can check again, I think it's between pi and minus pi and 2 pi. So we're only interested in minus pi. So we're only interested from this point here. We're only interested in answers from this point. Minus pi all the way to 2 pi. So this is the range we're interested in. Okay, so we're interested in minus pi theta all the way to 2 pi. So we're not interested in any other answer outside this range. So and the value we had that we're checking here was minus 1 over 3 minus 1 minus 1 over root 3. So let's assume that this point here, let's just pick any point. So let's just say this point here, it's red, right? So this point here is minus 1 over root 3, all right? So the same thing, minus 1 over root 3, you just draw a straight line throughout that. Then you also draw another straight line here. Yes. So now, but the range that we're interested in is only the point that touches within this part here. So you will see that it only touches at this one here, 1. It only touches at this point here, 2, and touches at this point here, 3. So that means within the range, although it touches at this point, you see that it is outside the range. This point is outside the range, so we're not going to take it. So we're expecting to have 3 answers, and that's why we also have 3 answers as well. Then we'll now see that we have the first one here, which is going to be the principal angle. And the answer we got for that, for the principal angle, was minus 1 over 6 pi. So that means this point here is minus 1 over 6 pi, or you can say minus 0.52, which I believe we said was minus 0.52, right? Yes. Now, the other solutions we're going to get, you're going to get one at this point here, and you're going to get another one at this point here, okay? So then let's call this A, and let's call this what? B, all right? So if you now look, so the one here is going to be the 5 over 6 pi. So this is going to be 5 over 6 pi, which is the same thing as 2.62. And here is going to be 11 over 6 pi, which is called 5.76. And that is that for that. So finally, we got to that point, and we're done with the question. So you see, we've solved questions on how to find the radians, how to work with radians. We've worked with degrees for sine, cosine, and tan. All right. So it's very important that you go back and review all these. I know it's a lot to take in. So you can go to the textbook and you can go and practice more questions for that. And that will bring me to the end of how to solve trig equation with multiple angles. We see sorry, not multiple. I meant with simple angles. All right, simple angles. Now the next video will be how do we solve trig equation with multiple angles. Okay, that was where I got it mixed up in my mind. So, but that's what we're going to. And for the multiple angles, it's very important that you also understand the simple angles first, because the multiple angles have some extra steps added to that. Okay. And also, another thing I need to keep in mind is that please don't forget to like, share, and subscribe, and click the notification bell. So when I post the next video on multiple angles, you'll be the first person to know. All right, thank you very much, and see you soon. Please don't forget that in order to solve this, you need to remember the 4 steps. You make sure all the trig angle is on the left-hand side. I also know that you have to find the trig inverse. You find the possible angle using the trig keys, and the range will determine where to stop. Okay, or let's say where and when. Okay, let's make it, let's add more to that. So it will determine where and when to stop. Okay. And when to stop, okay? So the range is going to determine that. Then in the exam, you have to sketch. So sketching is always optional. And you can change from degrees to radian or radian to degree, depending what you want to do. Then after you're done with all this, the next thing that you can do then is that You can also, if you're very comfortable with degrees or radian, you can work in any of them. Then at the end of the day, you change your answer back to what you were expecting, okay? And also, I also talked about how to get the first angle, second angle. So for the first angle, sine inverse, second angle, 180 minus theta. Or if it's in radian, it's going to be pi minus theta. If you're going the negative axis, you'll be minusing 360 or minusing 2 pi. And the positive axis, you'll be adding 360 or adding 2 pi. For tangent, the first angle is the tan inverse of theta. The second angle, you'll be adding 180 degrees or you'll be adding pi. If you're going the positive direction, same thing, you'll be adding 360 or you'll be adding 2 pi. And if you're going the negative, you'll be minusing 360 or minusing 2 pi. The cosine as well, exactly the same thing when you're going the negative or positive. But the difference here is that for the second angle, you're going to have 360 minus theta or 2 pi minus theta. And the first angle will be the cos inverse of that. All right, thank you very much. And I'll see you in the next video where we talk about solving trig equation with multiple angles. Thank you very much.